Okay, so let's tackle the heart of our changes, randomly selecting an answer. But how can we make our app do this? It's not like our app can reach into a hat and pull out a piece of paper with an answer on it. Wait, this one actually does have the answer we need. The Java random class. Java provides us with a sort of virtual hat from which we can pick a random number. The virtual hat object that does this for us is named random with a capital R. Now, we haven't talked much yet about objects directly, but we've been using and talking about them indirectly. Remember that Java is an object-oriented programming language, which means that it's built around this concept of objects. An object in Java is meant to represent some sort of object we can imagine working with that has its own properties and abilities. This is a different approach than just writing a script of commands for the computer to follow. We can think of it like this. The script approach is like watching an actor read lines from a screenplay, whereas the object-oriented approach is like controlling a character in a game who can interact with other characters or objects. I said that an object has its own properties and abilities. So in this game character example, if the character is considered as an object, then its properties might be its name and whether it is male or female, and its abilities could be things like walking and jumping. Objects in Java are represented by code that is organized into a class. Now, are objects and classes the same thing? Not exactly, but they're closely related. Think of a class as the blueprint from which objects are created. We've been working in this class called main activity. When we run our app, a main activity object is created from this code. So our activity is an object, and it has its own properties like its name, and its own methods, like the onCreate method we've been working in. Now try to imagine the random object as a physical object. Let's go back to that hat analogy. The random object only deals in numbers, so it's like a hat from which we can draw a random number on a little slip of paper. Getting a random number is an ability of the object, and abilities are represented as methods. We're going to be working with integer numbers, although other types of numbers like decimals are supported. The method to get a random integer is called nextInt. Alright, let's write some code to see how this all works. Under our comment on line 27, let's declare a variable named randomGenerator that is of the data type, or object in this case, of random with a capital R. Let's organize our imports with Command-Shift-O on a Mac or Control-Shift-O for Windows. Notice that the data type is an object. The string data type we've been using is actually an object too. There are different kinds of data types: simple or primitive data types that hold very simple data like a number, and more complex data types that are full-blown objects like the random number generator. Now we need to assign something to our random generator variable. Before the semicolon, type equals new random with some parentheses. This is called instantiating our object because we're making a new instance of it by using the new keyword and calling a special kind of method called a constructor. So in essence, we are telling the app to construct a new random number generator for us and assign it to the variable we just declared. Constructors like this have the same name as the class name, and they can have 0 or more parameters. We said that we're going to work with integer numbers, so let's declare a variable to hold the integer number generated by the random generator. The data type for simple integer numbers is int, so type int random number and a semicolon. The I in int is lowercase, which is a convention to indicate that this is a simple or primitive data type and not a more complex object like the random object. Now let's generate a random number and assign it to our variable. Before the semicolon, type equals random generator, then the dot for IntelliSense, and then select the nextInt method. This will give us a random integer, but we only want one of 3 choices, so we need to limit it somehow. There's another version of the nextInt method that takes a parameter that tells it how many numbers to choose from. So let's go back between the parentheses and type 3. Okay, let's save our work. Now seems like a good time to stop and make sure we have things working like we want them to. Instead of setting our label to a blank string stored in the answer variable, let's add a line of code to test our random number generator. On line 32, let's add a line and type answer equals integer dot toString with random number in the parentheses. Don't forget the semicolon, and save. This line converts our simple integer to a string so that we can use it like a string in the setText method on line 34. This is necessary because, even though the number looks like a string to us, computers store the data behind the scenes in very different formats, and we need to explicitly convert them back and forth. Notice that I use the toString method from the integer object. The integer object is a more complex representation of the primitive int data type. All right, let's run this and see what happens. Okay, if we click our button, we see the label get updated with different numbers. Cool. But why is it showing 0 sometimes? And it never shows 3, does it? It's showing us 3 different numbers like we told it to, but the list of numbers starts at 0 instead of 1, so we get 0, 1, and 2 instead of 1, 2, and 3. Well, at least we know that everything is working. We'll talk more about why it starts at 0 instead of 1 next. Well, the heart of our app is done, but the beauty and the devil is in the details. Onward and upward.